Hey there, I'm Kartik. I'm a principal data scientist at ThoughtWorks. I have around 2.5 decades of experience in this industry and almost a decade with ThoughtWorks. I head the data science and AI community at ThoughtWorks India, and one of my focus areas as part of GPT Wizards is doing active research in the area of generative AI and large language models to see how it can help enterprises. Today, me, along with JD, are excited to talk to you about one such work of ours, which lies at the intersection of legacy modernization and generative AI.
Hey everyone, this is JD. I'm in ThoughtWorks. It's been close to 15 years. I currently play the role of head of generative AI R&D and client partnerships in India, Middle East, and few other regions, working closely with the global AI pod of ThoughtWorks. I'm also founder of GPT Wizards, one of the groups that is helping us drive innovations around generative AI to solve some challenges around multiple industries and enterprises. Today, me and Kartik are going to talk to you about one such innovations called Legacy Bridge, which is playing a crucial role in the process of legacy transformation. So we're going to talk to you about what was the idea behind this tool, how we came up with the solutions, what are the challenges we faced, and what are the current features that we are working on this tool for further improving this one for better impact around legacy transformation.
Before we get started, let's quickly talk about the agenda for the session today. We'll get started talking about the big challenges that enterprises face while dealing with legacy systems. From there, we'll move on to talk about the ThoughtWorks journey in this space and some of the potential solutions that we have explored. And then we'll talk about the opportunity space and how generative AI can be helpful. And from there, we'll quickly move on to demonstrate our work and conclude the session by talking about some future direction for the work that we have done. So without further ado, let's get started. Quickly talking about the challenges faced by enterprises, we can bucket them into three distinct areas. One is the system challenges, another is the business agility, and third is the resource constraints. And as you will see as we move on in this session, that all three of them are in a way interrelated. The inherent nature of this technology and the challenges faced in integrating any new technology with this technology kind of impacts the business agility, and in a way the constraints in terms of skills and the cost also impacts the agility. So in a way all three of them are quite interrelated. We did a quick mining of various surveys done in this particular area by various other organizations, and what we found is that almost 60% of enterprises find it very challenging to work with this technology, and that's due to the inherent nature of this technology, which makes it very monolithic in nature. Also it often makes the agility come down. Almost 57% of the enterprises reported that they are not able to respond, having the core systems built using this technology. They are not able to respond to the business needs at the right time. And last but not the least, one of the focus areas for this session is around the skill shortage. Almost 75% of the enterprises report that they have major challenges finding the right set of people who can work on this particular technology. Not only this technology, but also people who knows this technology as well as the modern technology, which makes it even more challenging. So in terms of system challenges, if we go a step deeper, one of the other major issues that enterprises find is the project delays caused while working with this legacy technology. And as we spoke earlier, the monolithic architecture is at the root of this problem, which makes it difficult to integrate with any modern technologies. Also, more importantly, the security and compliance all issues are also much higher while working with this legacy technology, where the protocols are outdated, and enterprises, almost 50 to 55% of enterprises face issues making sure their applications are secure and compliant in this area. Almost equal amount of enterprises report that they find it almost very difficult to respond to the businesses. In lot of areas, domains like finance, the core operations of enterprises are built using this technology, and the customer facing solutions do not get upgraded with latest features or needs because of these issues. And the other challenge that we have been already talking about is the resource constraints, where almost 88% of CIOs report that skill shortage is one of their major challenge. And along with that, take into consideration the increase in cost. In 2023 alone, there's almost 50% increase in the software cost to deal with this legacy technology. We understand that almost there are around 800 billion lines of COBOL code in production currently, where most of the enterprises prefer modernization over replacement.
So now I'm going to quickly talk to you about how ThoughtWorks started with this creation of the solution of Legacy Bridge. So it all started with a client of ours visiting us here in India and on the month of May. And they started asking us, we have a bunch of COBOL code lying there, and we are trying to do some modernization of those code. And generative AI is hot at that point of time. Do you think GenAI can help us with do things a little bit better? And that was when we started thinking, okay, what are the procedures? And we started thinking about some solutions that where GenAI can help. In the month of July, we started evolving Legacy Bridge a little bit further. So we quickly figured out there are two problems with legacy codes like COBOL. One is understanding COBOL, and then there is translation, and both takes a significant amount of time. So we thought, okay, then why don't we break this solution into two parts? Okay, so was that okay? Even explanation is something where people are finding it challenging. So. And that brings us to start thinking about new user interface for people who are going to use this tool. So we kind of settled as of today where Legacy Bridge first provides you a crisp information or explanation of the code that is given to you. And then that code gets translated to the language that you choose. And then it also writes tests for the code that is generated. Now, the challenges that we have is basically COBOL. For example, if you take the example of COBOL is never a single program. It's an ecosystem, and this tool doesn't accept like an ecosystem of COBOL programs or legacy bridge legacy programs right now. So this is where we are working right now to understand if I give the entire COBOL system as an input to this system. Can it start understanding the business scenarios? But what it does brilliantly is explanation. So it explains the code. It also, unlike other tools on the month of May when the clients came in, they also said that, okay, we do use a commercialized tool for the explanation part. But one of the problem is that there's some predefined explanation that was that the commercial tool kind of comes up with. And this is where we thought, okay, obviously it needs to come up with some explanation when you provide it a code, but it should also utilize the natural language capability of generative AI. So we also said that, okay, we're going to create a chatbot along with the explanation so that a BA or a developer or a QA or any other in the team, if he or she has more questions, they can go and ask those in natural language, and probably we'll show you in the demo when we talk more about it. But that helped a lot. The translation, okay, it was. It's not that you translate and it just you can just replace your previous code. You can still, but it definitely gave some thought, some understanding to the developers, and that's how I think as of today it has achieved the goal to code translation. But we, as I said, we have to look further toward making it like providing it in the entire COBOL code, COBOL ecosystem. apart from the fact that we use GPT-4, as of today, what also evolved is that instead of COBOL code, it can also take any other legacy language that you provide and do the same task for you. And also, we have a lot of commercially usable open source models instead of GPT-4 is also used if you are too concerned about your data privacy and don't want to use a solution that is provided by the private cloud providers.
Thanks a lot, JD. Let's quickly move on to talk about some of the existing solutions that exist in this landscape and how generative AI can be used to solve some of these problems. Talking about some of the existing solutions, one of the things that we could potentially do is that there are some modern capabilities emerging within mainframes. However, the challenge that comes along with it is that we need people with the right knowledge, and also it involves upfront investment which could go up to around 4 million for a typical 2000 MIPS mainframe system. The other larger problem is that we need people who are expert in dealing with two kinds of technology. They should be good at legacy technology as well as the modern technology, so that they could effectively build systems which are useful in today's world as per the modern needs. The other thing that a lot of solutions have tried, where we could do code porting, where it could almost translate line by line from, say, a legacy technology like COBOL to modern technology like Java or .NET. However, this may not address the underlying architectural issues which are at the core of some of the problems that we. The other things that we have experienced within ThoughtWorks are making use of some of the commercial products like Visual COBOL from Micro Focus. It does allow to some extent where we could take up legacy applications and transform into .NET and JVM. But one of the areas that we have found is that it's not great at explaining the details. It's good at coming up with the high level data flow diagrams and architecture, but the in-depth analysis and in-depth understanding of why a particular piece of code is written, whether it is a functional requirement because of which it is written in a particular way, or it's purely a choice taken by a developer, some of those things still remain a challenge. Moving on, let's quickly now talk about how generative AI and large language models can be very useful in this area. As many of you must be aware, one of the early successes in utilizing large language models for enterprises uses is around code generation. And you must have heard about products like GitHub Copilots and other similar solutions that exist in market. Now, in an ideal scenario, if we are able to make or fine-tune a large language model to work with legacy systems, we could accelerate some of this modernization issues or challenges that we face. We can potentially make use of large language models to accelerate the modernization by not only doing line by line porting, but kind of also training the large language model to produce code as per the modern architecture, which might be or a microservice architecture which might be followed in Java or .NET for that matter. We can also potentially make use of large language models to provide debugging assistance, ensuring that the quality of the software goes up. And one other area is efficiencies in the workflows, where there might be personas in our teams who are not necessarily developers, but say QAs or business analysts, who still need to understand some amount of this legacy code to do their work efficiently. And that's where we see that if built the right way, a large language model can help them understand the functional pieces of this code or non-functional requirements to a larger extent by making use of the large language models. Another indirect advantage, if done the right way, could be given that we are able to produce the code with the modern architecture, with the modern programming language. We'll also have choices to make use of best practices, agile practices like CI/CD or TDD, etc., which would help improve the overall quality while working with some of these legacy applications.
So quickly looking at a logical diagram, this is not an architectural diagram to be very frank, but it kind of helps you understand how things works a little bit internally. So your legacy code, for the sake of this example, let's say it is a COBOL code. Once you provide, it goes through two stages. One is the code explanation and then the code translation. So your first mainframe code or COBOL code becomes an input for the LLM, where it kind of generates an explanation for the entire code that is provided. Now this is where we have our prompts to generate the explanation of the provided code in certain ways, certain format, where it explains each lines of code, also explains the purpose of the code, actual purpose of the code, what it is trying to achieve, etc. But in the same phase, you also have a contextualized chatbot where if you want to ask further questions, you can ask that. To give an example, let's say a BA going and asking, what is the business purpose of this code? What is the business challenge that this code is trying to solve? Or can you create a user story in given when then format for this part of the code which my developers are going to translate to a modern language, etc. Or let's say developers or QAs can go ahead and ask further explanation over and top of what is provided by the LLM, saying that, okay, I didn't understand these 3 lines. Can you further explain it a little better? And then you can also basically convert the entire explanation provided by the large language model and the conversations that you had through the chat bot to further explain certain areas or get some resources out of it into a PDF or any other format that you are looking for. After that, the code explanation becomes an input for the large language model again. And this is where the translation happens. So it basically understands what the code is trying to do and creates a similar translated code in a modern language. Now this is where the funny thing is that when we are working on it at the beginning, as I was saying, in the month of May, we provided the legacy code itself as an input for the large language model, and as a result of which what happened is the generated Java code, you will see a lot of systems.print.outln because it tried to mimic exactly what the COBOL code was trying to do. And then we changed this approach to make sure that, okay, let's say a developer who is trying to translate the code will probably try to understand what the code is trying to do and then create the related Java code for that. And that's what we try to do. The reason why we also provided you 2 LLMs, because this also opens the possibility of using multi-language model setup. For example, let's say we know that GPT-4 does a great job in explaining the code. So we can use a GPT-4 in this part of the code. But then we know that, let's say, when it comes to the translation part, open source commercially usable language model like CodeLama does a better job, and which actually we saw that it does a better job of translation. Then you can use that language model here, which is also a part of this setup. And at the end, you actually get this amazing code which is explained and translated for you. Great. So now let's look at a quick demo of the tool. So there are 2 videos that you get to see here where we recorded the demo. And the reason for this is in one of the videos, you'll get to see how we use GPT-4 to do the task. And the other video shows how CodeLama does the work, so that you get to know the difference of output between these 2 language models. But nevertheless, as I was saying, you can also combine these 2, and we have actually done that, where the GPT-4 does the explanation and CodeLama kind of does the translation part for you. All right, so let's quickly look at the first one. And this uses GPT-4, as you can see at the top. The code was provided in the previous stage. And here, let me just pause it for a bit. As you see, the explanation, this comes from the prompt that was provided to the application to come up with an explanation in a certain format. and it does a great job. GPT-4, to be very frank, does a great job of explanation. It does a very detailed explanation of the program, tries to understand the dependencies, the important features it's trying to do, and at the end, it also talks about the purpose of this code. But then in the right side part, you also have the contextualized chatbot that I was talking about, right? So if you want to know beyond this explanation as well, then you can come ahead and ask your questions. It is specifically useful for BAs or QAs or devs to further understand the question. If they have some specific questions, also it can get answered. So as you can see here, it kind of the question that was asked was to extract the business value, and it does a pretty good job of detailing that out. I think there was one more example, but let me just go ahead a little bit. If you see the next question that was asked, like give a user story for the code, and it does understand what is a story and how in Agile world you write a story, and it goes ahead and does that. So it becomes a foundational point for you to basically take this output and build at the top of it. Then you can go ahead and generate the Java code. It takes this explanation that it created as an input and starts creating, start translating the code. And if you see here, we have seen that it does a decent job, GPT-4, but you can still see there are a lot of system.print.out.ln, and in the next step, it's actually basically generating the tests for the generated Java code that it had. So I think, and then you can actually download the PDF if you want to share with your teammates. So now I will show you another implementation of this tool with CodeLama and how it is different, and we'll probably be giving the same code and we'll be asking the same questions so that you get to know how it is different. So if you see here, we are using now CodeLama in the drop down and pasting the same code out. You can also drop down, drag and drop your code if it is there. Also, this is a relatively small code, but we have tried with larger code as well, because in some certain cases this was also tried in actual projects. But when the explanation comes, you see here again the explanation part. I believe GPT-4, as I was mentioning, did a pretty good job of coming up with. This is also not bad, but I think the format and everything, the depth of explanation was much better in GPT-4. Even when you go ahead and ask certain questions, as you see here, the business value of the code, it is not as detailed as provided before by GPT-4. But if you go ahead and let me just fast forward this to the translation part, you'd see that the translation that comes out of CodeLama is much better than what comes out of GPT-4. And even the tests basically tries to concise the test in certain way. But in our knowledge, I think CodeLama does a better job of translating the code.
Thanks, JD, for the wonderful demo. We'll now quickly talk about the deployment architecture, what we have done using CodeLama. What we have basically done is that we purchased a hardware, which is an RTX 4090 NVIDIA GPU based hardware, which has around 48 GB RAM, 48 GB VRAM, my bad, and 128 GB of RAM. And we made use of this machine and we downloaded the CodeLama 7 billion model out here. And then on top of it, we made use of libraries and frameworks like VLLM and different libraries from Hugging Face to build an inference API, which could act as an endpoint for the client. And the client for this is the web app, which we built using Streamlit, which, making use of LangChain, can do the various functionality which you just saw. And this web app is used in a browser by a developer or a particular persona. Moving on, we'll quickly talk about the potential of CodeLama and why it could provide a major breakthrough. One of the reasons why we think that CodeLama could be very suitable is because of its ability to handle larger token size. Based on the latest research done by Meta and the CodeLama model, it can support up to 100k tokens. It is which kind of makes it very easy for us to handle large legacy code bases where there could be thousands or millions of line. Also, the other advantage of making use of CodeLama is that it comes with multiple variants. One is in terms of its parameter size, but also there are variants which are kind of fine-tuned for particular tasks. Like we have a variant of CodeLama which is particularly tailored for Python. Similarly, we could build something which is particularly tailored for legacy technology. Also, CodeLama's benchmark scores are doing almost comparable with respect to GPT-4, if I'm not wrong. In terms of the code generation, it has still much more work to do in terms of, say, code explanation or summarization, but we could potentially make use of multiple large language models for different things while building this entire solution. We could potentially talk about making use of CodeLama for code generation features or code translation features while making use of something like GPT-4, which could help summarizing or express the code in a natural language. So there could be an interplay of large language models while building this entire solutions, whereby we also get some cost benefits, latency benefits, and overall the solutions will be much more efficient and much more performant.
So before we wrap up, just wanted to quickly highlight where the tool is today and what are the things that we are looking into for the future improvements. So I think most of the things we have already discussed. So as a POC developed by a group called GPT Wizards in ThoughtWorks, and as of today, the tool does a great job of explaining. Translation may not be the case, but the actual challenge is that a legacy code base like COBOL is a COBOL ecosystem, and there are many interlinked COBOL programs which basically shows a single functionality or business functionality. So the current tool doesn't do that, and this is what we are looking at right now to improve the tool further. And in future, we are also kind of trying to understand if we can use generative AI or other models to come up with a dependency diagram where when you provide a bunch of COBOL programs, can it quickly draw a dependency diagram of the COBOL programs so that it is easier to navigate through them. And the third one, I think it already does as we speak. It's being deployed. Legacy Bridge can also support now like legacy codes other than COBOL. And it can also translate to any other languages apart from Java. And the last but not the least that we'll be working towards is basically the business side capabilities. Can COBOL program, can generative AI basically understand the COBOL ecosystem to reduce or shorten the scope of translations? You'll see many times there are like thousands and thousands lines of code that are not being used, but we are scared to remove that because we don't know how how the COBOL programs are dependent. So I think this is another area or the feature that we'll look at for the future stuff as well.